Hello everyone, Code Purpose here. We are going on with our 28th exercise named Sums in a Triangle. This exercise is a bit harder than the exercise you solved before this, but I'm sure that you'll get it from the explanation we are going to do. Let's start reading the text. The text says, let's consider a triangle of numbers in which a number appears in the first line, two numbers in the second, three in the third, four in the fourth, and so on. We need to develop a program that will compute the largest of the sums of numbers that appear on the path of the starting from top towards the base, so that on each path the next number is located on the row below, more precisely either directly below or below and placed on the right. This is very helpful information. And we have some constraints. The number of rows is strictly positive but is less than 100, and all numbers are positive integers between 0 and 99. So in the first line we read n, which is number of test cases, and in the next n lines we read a triangle, which triangle would be a matrix in this case, and for that triangle we need to find the biggest sum. So I have an example of my own here. I have this example. So our input is, we have a 5-line matrix. First line is this, second this, third is this, and depending on that which line is it, we have that amount of numbers. So if we see this as a triangle, we can see that we have two paths for the number 7. Then we have two paths from the number 3 and two paths from the number 8. After that, each one goes more, has more, and paths are dividing more and more. So in each turn we have more paths as a result, and at the end we have 10 paths. So we need to find, starting from 7 going down there, to find the maximum value. In this case that would be this combination, this row 7 3 8 7 5, which where the result would be 30. And how we are going to solve this? The main idea is, in the exercise, as we can see, in the first line it says that the next number in the next line is located right below or next one next in the right. So this is a triangle, and we have here left right, but when we read the input, for example here, this is the way how matrix looks. We have one down and one right, so probably we'd get the bigger number, but we can't start from the beginning and to know which is the maximum. We could choose here 8, but then we wouldn't get the expected result, because maybe, as we can see here, there are other numbers, for example 1 0 we have here, and we lose. But in this side we have 7 3, which is 10, but in the right side we have 7 8, which is 15. It's bigger, but in the next step we have an 8 here, and the number 3 is greater than 1 or 0, and that number make the sum bigger, and that's why we need to go this way. So what are we going to do? We are going to start not from the top and go down, but we are going to start from the base and go up there. So we are going to ignore the last line, and we are going to start from the not last one. In this case, you have 1 2 3 4 5. We are going to start from the fourth line, or n-1 line, and we are going to add to each number, to all those numbers, the maximum number that they can get from there down. For example, 4 and 5 is greater than this, so to the 2 we add 5 and this number becomes 7. Then to the 7 we add again 5 and this becomes 12, and so on. This becomes 10, and again this becomes 10. After that we move on one line upper, and we repeat this again. To the 8 we give the biggest number of those two, so here we have 20. From 12 and 10, bigger number is 12. Here we'll have 13, and here we have 10. No matter in which direction we go, it's the same number. After doing this, we are going again one line upper. So to the number 3, as we see the chain which going from the top to the bottom, it get bigger and bigger. We had more cases and more cases. Going from the bottom and through the upper triangle number, it gets lower and lower. So from 20 and 13 we add 20 to the 30, and we have 23, 13 to the 8, and we have 21, and at the end to the number 7 we add the bigger of those two, which is 23. 23 plus 7 is 30, and at the end we output the first element of the matrix, the first element in the first line. That's our maximum value as a result. So let's start writing this like a code. Firstly, we had the number of test cases, and we have an number of rows on the matrix, numbers of rows and columns. We'll do that to be a squared matrix, because we know that we in the first line, if we have the input n of 5, in the first line we are going to have one number, but in the last line we are going to have 5 numbers. So we have 5 rows, and the maximum number of elements in a row is 5. So that would be a square matrix n of n elements. So let's go on and firstly read the t. K is equal to 0, k is less than t. Okay, it's better because when I read the matrix I prefer to use I and H. It's better. And here I declared and there I just need to read it, sin n, and here I'm declaring a matrix of n of n, a square matrix with n rows and columns. So I have a 4 cycle. The 4 cycles, it has n rows, that's why it iterates until the end, but each row has I element. So in the first line we have only one element, and that would be a of 0 of 0. In the second line we have a of 1 0 and a of 1 1. So firstly we read them of each, and we get as an input, for example, this is A00, A10, A11, 20, 21, 22, where the first number is A and the second number is H, the number of the row and the number of the column. So after reading them, we said that we are going to start from the not last, but before the last row is n minus 1. So I would be not n minus 1, minus 1, minus 1, minus 1, it's equal to minus 2, and it goes until it reaches to 0. So it needs a semicolon there, not just a column, and decreasing, going up, not down in this case. And after that we have the second fork. The second fork is going to start from 0 and until it reach I, because if I is 4, it means it's less than I, sorry, because I is 4, it means that there are 4 elements, but in this case I would be 3, and that means that it has 4 elements, because the arrays go from 0 to n minus 1, counting the 0 we have every time 1 element plus the number we have, and we have H++. So here we have an if else condition. We say if the number which is below, if we check carefully, we have 0 0, 0 1, 1 0, sorry, and 1 1. So we have the I plus 1 and the H is the same, and we have I plus 1, H plus 1. So we need to check which one is greater. So if A of I plus 1 of H is greater than A of I plus 1 H plus 1, then A of I of H, the element we are currently finding the maximum, which is downside him, below him, gets increased to A of I plus 1 H. Otherwise, A of the element we are right now increases to the element that is below him but one place in the right side. H plus 1, semicolon there, and after the second while side for second for cycle, outer for cycle, and we just output A of 0 of the 0 and line. So let's copy this code, go here, click the submit button, open it into a new tab, and paste there firstly the code. After pasting the code, we get in there and copy the input example. We put their custom input, we put that there, and we run it, and here we have 59. That was our expectation. And let's try now other test cases that they have. If we have a 100% correction, yeah, we have 100% correction. I hope that you understand that what we explained about the exercise. If you have any questions, freely comment below and we'll try to answer as soon as possible. Thanks for watching. We came to the end of the 28th video. Don't forget to subscribe by clicking the red button right below the like button, and also turn on notification by clicking the notification bell to not miss the upcoming videos. See you soon on Code Purpose.